Hi everyone, my name is James Duke. I'm in our strategic cloud engineering group in our professional services team. I'm here with Shahid.
I'm Shahid. I'm also a strategic cloud engineer in the Google Cloud Professional Services.
And we're going to talk to you today a little bit about the practical guide to, what do we call it? Practical guide to modernizing applications for containers. If folks have questions, there is a Dory. Please feel free to use it. If you open your app, you should have a link to it from the next app. If you fire questions into there, we'll come back at the end and address those questions. We'll also take live questions. We have a microphone. So as we said, it's the end of the day, right? So we'll take it's going to be a fairly casual experience. We're just going to have a chat. It's like you guys are watching our chat. Right? We're talking through this process a little bit. So what are our goals, Shahid?
So our goals are really three things. We want to understand what modern applications look like. What are some of the terms or buzzwords you hear associated with modern applications like containers, microservices, cloud native, and so on and so forth, and why they're important. What do they mean for your business? Why would you want to build applications that are cloud native or that run as containers and so on and so forth? And then the real meat of our session is in how. How can you get your application migrated over so it uses some of those design patterns that we'll discuss. So those are really the three main goals of this session.
Yeah, in the first two, we'll kind of level set a little bit. You know, we'll talk about the definitions of some of these things, the pros and cons and that kind of stuff. And then we'll talk about what does a journey to a modern application look like today. So let's start with what.
Yeah.
So Shahid, what is a container?
So yes, so containers, you hear a lot of buzzwords associated with containers, that they're lightweight, portable, fast, and so on and so forth. So let's look at what does this really mean? So containers in themselves are really about two technologies. First, it's a way of packaging your application and all of its dependencies into a single image. And then the second capability is the ability to run that image in an isolated set of processes. So those are sort of really the two main things that containers provide you. They let you package everything that your application needs into one single image and then provide you a mechanism to run that image in an isolated manner. So that's really what this is. And the key term here is process. So containers run as processes. So just like when you start something on your computer, it starts a process in the background, it runs as a process. Containers run the same way. And containers are a group of processes that sort of work together to provide some functionality that you need.
So who here has built and deployed a container? Show of hands. Okay, not bad. Looks like about half, I would say. Who's used some kind of container orchestration system, Kubernetes, Mesos, OpenStack? Okay, about a third. Okay, that's good. That's good. That helps us with the level setting for where we go through this. So for those of you who've deployed it, you'll be very familiar with this. Right? It gives you this nice packaging, you get the application, you get the dependencies. For those who are less familiar with it, this may be a new concept, but the idea is that I only depend on an environment to execute the container. I don't have to care about bringing in libraries, I don't have to care about bringing in dependencies because I've packaged them all up into my container.
So let's look at how containers and some other ways of running your application sort of compare. Some of you might be familiar with this kind of a diagram which shows what running applications on a shared host looks like. And that's basically the host provides the kernel and it provides also the libraries that your applications need. And then all of the applications that are running on that host share that kernel and the libraries. The challenge with this kind of setup is since the libraries are shared, you have to be really careful which version of which library is installed on that VM. And for that reason, a lot of the time, people actually run one application per host. So they run one application, they bring all the dependencies that they need, they bring it to that host, configure the host to be the right kind of environment for that application, and then run it there.
And in many ways, that's very convenient, right? Because we now have a kind of a logical grouping of our applications, should I say. The problem is there's kind of minimal boundaries between those applications. You can do some stuff with sandboxing, but generally speaking, in this model, those applications, they're all in a shared space. And so I don't have any minimal security boundaries between those things. So that doesn't help me when those applications should be isolated from one another. So if we go up the stack a little bit, we think the next thing we might think about is VMs, right? Well, why don't we take those applications, those dependencies, and now we can fit multiple single host application servers onto one physical machine. People talk about bin packing, right? We're now more effectively using more of that machine's resources because we have more things running than we were able to before. But the trade-off here, of course, is the libraries are not common. So now, and not just the libraries, the kernel. So now, in a given host, given physical machine, I'm running multiple kernels. And there's a huge overhead. Well, there is an overhead for having done that, right? Each kernel there will use its own set of resources, CPU, memory, and its boot up time is a factor, right? Every time I boot a kernel, there is a time penalty in doing so. Okay, modern, especially Linux-based ones, modern kernels can boot very quickly, but there's still a penalty there because you still have to do it.
Yeah. It can take a matter of minutes for a VM to boot up. And it does provide a lot of isolation, as we were saying, but the cost is that it's not very flexible. If you need to resize a VM, if you need to give it more resources, you have to really essentially rebuild that VM. So that's where people went to container technology. Google was one of the pioneers in that technology. All of our workloads internally run as containers predominantly. So the containers provide isolation within one host. So instead of breaking up that host into individual VMs, we use some of the mechanisms that are available in the kernel, in the Linux kernel, to isolate a set of processes from another set of processes, and each of those set is a container. The great thing is that they share the same kernel, so once the host has booted up, the kernel has loaded, there's no more delay in launching these containers. And starting each of these containers is like running a process. As soon as you type in a command on your laptop, for example, the application comes up quickly. It doesn't have to wait for your machine to boot up. Yes. So that's some of the advantages of using containers.
Yeah, it totally removes that kernel boot time that I was talking about for the VMs, right? It uses the same kernel. The kernel's already running, you just spin up another process. And the reason we're kind of doubling down on that is when we're talking a minute about what does a cloud native computing look like, one of the most important parts is scalability. And to me, when someone says, I'm going to build a cloud native application, that means it's going to be very scalable, right? And VMs, they can scale very well, but imagine a scenario, let's say, well, like an unnamed company who may or may not have released a new product this morning. Imagine that your press release generated a bunch of traffic to your application. You need to be able to respond to that very quickly. If you have to wait for kernels to boot up, that might result, even if it is only a minute or two, that may result in a poor experience for your users, and that's especially concerning if it's the first time they're experiencing your system. Right? There's nothing worse than sitting on a loading screen the first time you ever use a product to turn you away from using it. And so with containers, that's not a problem, right? If you want to spin, I mean, within reason, right? It depends on how many containers you can fit on a given kernel. But within reason, it allows you to scale much, much, much faster because you don't have that boot time penalty.
One drawback with containers is that there's, even though there's less dependency on the host, there's still a dependency on the kernel. Since the kernel is shared, you have to target a particular kernel. But the good thing is these days, Linux kernel is pretty standard, so a lot of applications target the Linux kernel and can run as containers. So with that in mind, let's revisit some of those buzzwords to see if you have a better appreciation of what that means. So as we described it, containers are lightweight, and it's true because they don't have the overhead of creating a full VM. Mm-hmm. So virtual machine, when you create one, you have to provide the host OS image on it, libraries and everything that you need to run your application.
And in a container, you only put in what you need, right? You're able to specify just the bare minimum set of things that the application needs in order to do its job. So you can end up with containers that are very, very, very small from an actual disk space perspective.
And they are portable because you're bringing all your dependencies with you. So any libraries that you need, you're bringing with you. And all you need on the host is really the kernel and some runtime that can run your container. And those are pretty standard these days, the container runtimes, and it's pretty easy to install that on any host. So that's what makes your containers portable. And if it's not just portable from one VM to the other, but it's also portable across environments. You can run the same container on-prem and on any sort of cloud provider as well. And that's, yeah, go ahead.
Who caught the keynote this morning? You see the keynote speech? Yeah, so you saw our glorious leaders talking about Anthos and what Anthos brings to the table. So in a world where you have so Anthos fundamentally builds on the construct of a container, right? If you have a world where you have that hybrid multi-cloud environment, once your application is containerized, moving it between those clouds or between those environments is very, very, very straightforward. So if you have a platform where you can orchestrate all of your security, your networking, your monitoring, with your service mesh and everything, and your configuration management all across those different environments, the question is not, can I move it? The question is, where would be the optimal place for that particular workload or that particular application? And so when we say portable, that's really what we're talking about. It's not moving it from one VM to the other. It's much broader than that. It's how do I put this application so it's as close to my user as possible? Or maybe it's something as simple as this one particular platform is more cost effective for the type of workload that I'm running. Whatever it might be, it gives you the power to choose to run your application wherever you want. It's this old phrase, right? Yeah. Build once, run anywhere.
And then they start fast. So as we said, since there's no overhead of starting a VM, your containers start as processes would on an ordinary host. So they start in, I shouldn't say boot, but they start in a matter of seconds. And as long as your process needs to start taking traffic, that's all it takes for it to do that. So let's quickly demo one, just see how the containers look running from the host point of view as well as the container itself. So here I have a Google Cloud VM, and I'm going to run a container image that I've created and push to one of the container registries that we have. So I'm going to use the docker run command to run this container. And once I run that, it has started that container over here. So when
See how fast it was?
Yeah,
See how fast it was? Yeah. No kernel boot time.
So since I had downloaded the image earlier on this VM, it didn't even take time to sort of start that. So let's look at the, if I look at what images are running, this is the image that's been running, and it's been up 18 seconds since I just started it. And so let's look at what the process tree looks like from, on the VM. So as you can see, this is the VM. So I'm looking at the host. I'm looking at all the processes that are running. So this is everything that's running on the host. And part of that tree you will see is the container D, which is our container runtime, and the Nginx process that I just started as a container. So you'll see this is just one set of processes within the other processes that are running on that host. So there's nothing special from the host point of view for these processes other than it's just grouped together and it has certain boundaries associated with that. Next, what I can do is I can look inside that container, and I can, I can attach myself to that container and see what the process tree looks like from within that container. So what I can do is I can start another command inside that container by using the exec command. So you see the command prompt has changed here, and now I am in the context of that container. This may look very similar to a VM. When you log into a VM, you have a certain command prompt and so on. So if I look at the process tree within the container, you'll see it's a very limited set of processes. It doesn't even see the container D process, that's the parent or the container shim. It only sees the Nginx processes that I started. And since I'm running the PS command and I just started the BA shell, you see that as well. So from the container point of view, it has the whole host available to itself. It doesn't see any other processes. It cannot interact with any other processes. So that's where that isolation comes in. But from the point of view of the host, you can see pretty much everything that's running on the host. So that's what the difference is. There's no magic here. It's just processes that have been sort of put in this sandbox or a container that you see.
In actual fact, the Linux kernel has no concept of a container. It's a purely user space construct. So it's just built up of processes that are sandboxed from one another. And the reason we're going into this in detail is because, as you can see, Shahid right there has, do you have root on this machine? Are you root here?
I might be, I'm not sure.
Yeah. Shahid can look inside all of that process tree.
Yeah.
That is to say, if you have sufficient permissions on the host, then any containers that are running in that are potentially visible to you. right? So when we talk about security and we talk about how to secure a cluster and how to run secure clusters, it's not just about the containers, it's not just about the namespaces, it's also about the operating system level access as well.
All right. We can switch back to the slides. So let's look at some of the other terminology that we talked about. So what are microservices? Again, the things you see associated with microservices are that they're loosely coupled, they're sort of fine-grained, they provide some minimal set of functionality that's useful, and they make you more agile, and they should be testable on their own, and so on and so forth.
Who's built or deployed microservices? Okay, about a quarter, I would say. Okay. So for those of you who've done it, like, what was the thinking? What was the reasoning there? Someone shout out. Why go microservices? Yes. Extract business logic from your monolith. Excellent. We got one more. Break up the monolith to improve scalability. Also excellent. All of these things, they are absolutely the value of the microservices. So let's dig into the two of those and use those to explain the buzzword. So separate the business logic from the monolith. In a moment, we'll talk about why I use these things, but the short version of that is these are tools, and tools should be used to solve business problems. Technology just by itself, while very cool, and it's obviously a passion of mine, it doesn't solve real-world problems by being cool technology. It solves real-world problems by being applied in the right way to real-world problems. And so to the point of extracting the business logic, having everything tied up in one thing, it makes it very difficult for you to focus on the things that are important for your business or for your customers' businesses, because there's so much other stuff wrapped around it in this giant, sprawling, in some cases, decades-old piece of software. And it becomes very difficult to say, okay, well, it's now 2019, I need to do some stuff because the market's changed, my competitors have changed, I have a new idea. And it makes it very difficult to do that when it comes with all the other craft. And the same is true of the scaling piece, right? If I have a monolith and I suddenly have the success disaster scenario I described earlier, I get 100 or 1,000x traffic that I do on a usual basis. To scale that, I have to either absorb it in the existing monolith or recreate instances of the monolith and manage traffic between those instances. And that is can be a very, very painful thing to do, because often those monoliths are not designed to spin up quickly. They have a bunch of dependencies. In some cases, they run on specific hardware. There's all sorts of reasons why that can become very difficult. But if you break each part of that monolith out into its own microservice, now I can scale each one of those services independently. I can modify and update each one of those independently to change the business logic, to add new features. In summary, it makes us more agile because it allows us to respond to changing market conditions and indeed changing technology conditions as well.
And testing the same thing. Once you have a smaller piece of functionality that you have to test, your releases are quicker because you don't have to worry about testing all the features that you've built into this big monolith. So I hope with these you have a better understanding of why the industry has been moving towards microservices. Next, let's look at the cloud native. So cloud native, means built for the cloud or sort of born in the cloud, if you will. And typically, you hear that if you want to build for the cloud, you have to use containers, you have to be a microservices architecture, and what it'll give you is quicker releases and scalability and all that. Some of these reasons we saw earlier. When we looked at containers, you saw that containers are easy to sort of deploy from one place to the other. You don't have to prepare the infrastructure as much to run your container because you're bringing all the bits that you need with you. So you're building the bits, and the infrastructure is just providing the compute and other resources that you need.
But it is important to note the three things are different, though. Right? A containerized application is not necessarily the same as a microservices architecture. Yeah. They often go hand in hand, but it's not necessarily true. And you could do both of those things and still not be cloud native. Or you could be cloud native and do neither of those things. The three are not necessarily the same. We do typically see them coming together, though. The majority, certainly from what we see with our customers and in the broader IT and computing industry, we have seen typically a cloud native application displays a microservices architecture, and it's usually containerized. Especially when we look at something like Anthos, right, which it naturally leads towards a containerized and microservices model. And all of the three things together is where we kind of see the future of our field going.
Yeah.
So that's what. Now why? So we touched on this a little bit. Shahid, why should we use containers?
So I see containers and microservices and all these as enabling technologies. So they do not bring necessarily benefit in themselves. They enable you to sort of reap the benefits of the modern infrastructure that's available in the cloud. So that's how you should think about it. This is not a means, this is not the end in itself, it's a means to an end. And you get all of the benefits that we talked about that you get from containers. You get the portability, the scaling up and down, fast scaling up and down, and portability and all that with that. And it opens up a lot of options for you. You can run the same container in a VM. You can run it in a platform like Kubernetes, or you can run it even in serverless platforms like Cloud Run and so on. And similarly, microservices and containers together provide some of the benefits that we talked about. You can scale up your application quicker, but again, your application has to be built in such a way still that it can be scaled up easily. And we'll see that when we look at how to think about that when you're designing your application, or as you're converting your monolith into a microservices or a modern architecture.
Sure. So do you want to talk a little bit about what the options are for where we can run these containers?
Yeah, and quicker release cycles are basically, since it's not a big application that you're releasing, your microservices are smaller, so it's easier to manage the releases. When you have, if you think about it, when you start off a project, it's easy to sort of iterate on the code. As the code base grows bigger, then it becomes challenging. So keeping it in microservices forces you sort of to keep that code base smaller as you're separating out your business logic into individual repos and individual release cycles. So what that gives you is that once you have the image, once you've built the image the right way, you can now run it in many different types of infrastructure. And here's some examples with just, once you've built your image, just hello world in this example, with one command you can run it, you can pick the runtime that you want, and you can deploy the same image in any of these products that Google Cloud Platform offers.
Yes, so very simple, right? 4 different commands, and you have the same container running in 4 different infrastructures, or 4 different platforms, should I say. And so when we talk about portability, like this is what it looks like in practice, right? Now, in reality, this is a little bit of a trite example, right? Because most people aren't pushing a single container with a single command. More than likely, it would be in some kind of orchestration platform. But the same thing holds true across the different orchestration platforms too.
Yeah. So here you can look at, you can't just at random pick, one day, I'm going to run my app in App Engine or Cloud Run.
Well, you could.
You could.
I wouldn't recommend that. You could.
You can once you have the container built. But here's some guidance on how you can pick the right runtime. And the way to look at it is it's sort of a continuum. On one end, you have pure infrastructure that gives you a lot of flexibility of how you want to manage that infrastructure. For example, VMs, you can pick the image that you want to deploy on your VM. You can configure it the way you want to. You can put libraries that you want to on it, and then you can run your container on it. And that's one option. And what you're getting is a lot of control. What you're giving up is, or what you're, I guess, signing up for, I should say, is now you have to maintain that VM. Since you created a custom VM, you have to make sure that any updates that are needed are applied to that. And as you move in the stack to the right, you start giving up that control. You're letting the platform or your cloud hosting provider take on some of those responsibilities of operational aspects of your infrastructure, and you're focusing more and more on just your workload. But your workload has to conform to to sort of the APIs or standards that platform expects it to have. So that's the trade-off involved in moving from left to the right of this. And eventually, the new sort of nirvana is serverless, where you're not worried about your infrastructure at all, and you're letting your cloud provider provide the infrastructure for you based on your workload. And all you're providing is, again, your image, which is exactly the bits that you need, the software that you need, and nothing extra, and you're letting your hosting provider provide the underlying infrastructure for you.
Absolutely. Okay, we've teased it enough. We've done all the background, done the level setting. Let's jump into how we might actually do this, right? Because it seems like a daunting task. You're faced with a giant monolith, like I said, could be decades old. It's a daunting, daunting task to take on and say, okay, I want to actually change this. Where do I start? So we've kind of, well, I mean, we didn't come up with this approach. It's been around for a while. But we wanted to share with you some things today that we found to be effective when we've done this with our own customers, and as a suggestion for ways that you folks could do the same. So first step, you need a list. You need to know, what do you have? What does it look like? Where is it running? What does it do? What technologies does it involve? What are its dependencies? And more to the point, what group is it in? So classifying it on the basis of a number of things. So we kind of came up with these 3 groups, right?
Yep.
So we start off with stateless applications. As you might imagine, stateless applications tend to be the easiest group to deal with, and so we tend to deal with them first. Things like web front ends, existing services, maybe they're micro, maybe they're not, and existing APIs that just take in data, transform, and send out that data. Anything that has no state, anything that takes a request, gives a response, but doesn't rely on some kind of underlying state. We group all of those together, and they tend to be our first movers. That tends to be our first place to go. Web front ends in particular seem to be a very popular approach. Part of the reason for this is you want this first mover to be non-trivial. You don't necessarily want it to be the #1 revenue generator for the business, because the first time you do this is a bit of a learning curve. But you do want it to be something that's meaningful and that has some kind of real-world use, because if you just start with a hello world application that nobody uses, it doesn't really prove anything out. So often we'll find that web front ends, whilst they are in the critical path for a lot of user journeys, they tend not to be, well, hopefully, they tend not to be too complicated and are stateless usually, and so lend themselves very well to this first group.
Yeah.
Then the second group, temporary state. What do we mean by temporary state?
So temporary state is something where an application, when it starts up, it starts building up its state. It doesn't sort of persist that state between startups, and a typical example is a caching application, Redis or Memcache or anything like that. When it starts up, it doesn't have any state, but as people put items in that cache, it starts building up. And if you had to restart that, it's not a catastrophic event. You can restart it, but you'll suffer some loss in response time, or there might be some errors that you might see as it's restarting. Similarly, applications that sort of take on different role once they start up. For example, you could have a master and a slave. When they start up, they are all the same, but then they somehow coordinate to pick one master, things like that. Redis has that, and there are other examples of that as well. So this is sort of the second group that we've come up with, and we're calling it temporary state because, again, that state is not persisted across restarts. It's something that it acquires as it's running. So these can be great second movers because, again, you have once you have the knowledge of what does it take to run applications as containers in a more dynamic environment, you are ready to take on the challenging of how to build that state dynamically. How can you elect a master when the existing master dies without someone manually intervening and so on? Or how can you build up maybe the cache from other replicas and sort of redistribute cache as one of the replicas dies or something like that? So that's why this is our second group that you should look at.
And then thirdly and finally, stateful applications. Databases, file servers, and raw storage. It's not impossible. In fact, it's very doable to move stateful applications into a containerized or microservices architecture. But it's more complicated than the prior ones. Typically, many, especially more legacy databases, aren't necessarily set up to just add more nodes to get more capacity, right? They have a concept of master and slave, but in a very different way. They're often not dynamically deciding and voting and promoting new masters. Some do, but many don't. And so these probably want to be the last thing that you would consider. largely because they benefit the least. Yeah. They benefit the least from migrating to this new paradigm, and they have the least amount of benefit for most complexity to actually change them as well.
And how many of you have tried scaling MySQL database, for example? You can't just add a replica and expect it to work out of the box. So it requires some sort of manual design and decisions that you have to do, that you can't just say, oh, I need another MySQL instance and just add it there and go from there. So that's why these are more difficult to sort of containerize. And the benefit isn't as much there, because you won't be scaling these up and down dynamically to begin with.
So first step, list and group. Second step, containerize parts of the application. In most cases, you probably don't want to go, well, it's possible to go do a big bang approach to all of this. Say, hey, you know what? We're going to take our whole company out of our regular release schedule for 6 weeks or 3 weeks, and we're going to go just do the whole thing. We're going to take the whole application, wrap it up in containers, and release it out. Lovely in practice, very, very, very difficult to do lovely in theory, very, very difficult to do in practice. In practice, in most cases, most real-world scenarios, you'll want to do this one step at a time. So once you have your list and your groupings and your priorities, then it becomes about finding parts of that application to move to those containers first.
All right.
So, some examples. The most basic example of all of this is take the monolith and put it into a container, right? It's the fastest way. And technically, you now have a containerized workload, right? Check the box. Yes, I can do containers. It's quick to deploy and actually can be automated, which we'll come to in a second. This allows you to prove out the concept. It allows you to get comfortable with the technology. And depending on the nature of the monolith, may allow some scaling that wasn't possible before. But you don't really get the full benefit. Having said that, it can be a very worthwhile exercise, both from a learning perspective, but also from a I need to move right now perspective. And the reality is, many times in the projects that we've seen, there is some kind of compelling event. Yes. Black Friday, Cyber Monday, a holiday, a sports event, or even something as mundane as a data center lease expiry. I have to get out of my data center by April 29th, whatever it might be.
So this is part of sort of the lift and shift kind of migration, where you're lifting the application, just containerizing it and shifting it to as a container to the cloud. And this can be done in many times. There are ways to do this automatically. In fact, if you saw the keynote this morning, you saw an example of an app being migrated from a VM into Kubernetes engine running as containers. So there's Anthos Migrate, which helps you do this automatically. So you can do it manually as well, but there are instances where you can just use the automated service like Anthos to do it for you as well. So again, this can be a good start to your journey.
So the next approach would be, okay, so let's think about how we would migrate some parts of a 3-tier application, right? So in many cases, the way you would do this, you would be put this behind a load balancer, right? Put a load balancer in front of, you may already have one, but put one behind the Google Cloud load balancer, and then we can look at the app front end and the app back end. Remember we said these are the pieces that don't necessarily store state. Maybe the back end might be one of our semi-state applications. The front end would typically be no state. And then what we can do is wrap those up in containers. And now we can scale those tiers individually. So if we have that success disaster scenario, I can rapidly scale up my front end to handle those requests without necessarily having to do the same scaling to my back end. Now, of course, you may end up with contention to the database in that scenario, but at least it allows you to respond. At the very least, allows you to respond with a, we're working on it, we'll get back to you, instead of just returning a 404 or a 503.
One thing to clarify is that red box does not show one container boundary. You want to, the white boxes are really containers, so you want to run the front end separately in a separate container and the back end separately. And this is a nice transition from a monolith as well. This could be the first step at breaking up a monolith. Typically, the web front end part of a monolith is easy to break out. So you can start with that, and you can separate that out, modernize it using some new technology and leave the rest of the monolith running as the back end for that front end. So this could be a good starting point on your journey.
But we're still not all the way there, right? We still don't get all the benefits. So what can we go to next where we get a little bit more of the benefits we were talking about? So we can start to think about a transitional microservices architecture. We're still kind of mostly in a monolith mode here, but we're kind of dipping our toes in the water a little bit. We're going to say, well, okay, one small part of that monolith we're going to break out and build into a separate service. And in some cases, this might actually be completely new functionality. We've actually seen both work, where we've had customers that have built a new function or a new feature as a new microservice and left everything else in a monolith. We've also seen folks who said, well, actually, you know what? This one particular part of my monolith, I can carve that out and recreate that same functionality, that same feature, in a separate service. You might, now, likely, that means you have dead code, right? There's probably code left in that legacy backend that now no longer operates. And that introduces some problems, right? You may have code duplication, so maybe some technical debt to remove that out later in time. It may be possible to remove it there and then. That's really very dependent on the particular application that we're working with. But the basic principle goes, take a piece out, move it over there. And now that piece can scale very easily, and then we don't have to really affect the existing monolith. There's very little appetite for changing the monolith in a lot of the customers we work with, especially things that are in a more regulated industry or in a more traditional enterprise type space where they don't really want to touch it because it has been running that way for 10 years, and they're very nervous about changes breaking it. So when we do it like this, we don't have to touch that monolith. We can leave it well alone, so there's very little risk to the business.
Yeah. And this is a great way of reducing risk as you're migrating, because taking small steps, making small changes reduces your risk. You don't have to worry about making a big change and upsetting something that you didn't even know might go wrong when you start peeling things. The other thing is, when you take small steps, it's easier to sort of estimate what you would need to do, and you can apply your learnings to the next steps that you will take as well. So the first time you're building a microservice, you might be learning a lot, and you can apply those learnings as you build more and more microservices. If you start with 4 or 5, you might, you'll be repeating the same mistakes across 4 or 5 work streams that you could avoid by doing one change at a time.
So then the next step is, let's add an API gateway. And now the API gateway becomes the arbiter of where all traffic goes. So anytime a request comes in, it can come directly from the load balancer in some cases, or it can come from the application front end. Now the API gateway decides where traffic goes. So very minimal changes, well, no changes required to the front end, except pointing at a different IP address or service name. Yeah. And now the API gateway gets to decide, okay, which backend do I need to send this request to? Is this something that I need to send over to the backend, the legacy backend, the monolith, or is this something that I can send to one of these fancy new microservices that we have? And this is particularly powerful because, think about this, as you add service B, C, D, E, and so on, now the only piece that has to change to support those new services is the API gateway. So it becomes a single point of configuration that's basically routing your traffic from monolith or microservice.
So it gives you that flexibility of where to send that traffic, and it hides that detail of what microservices you actually have running behind the scenes from your clients, from the consumers of those services. So they don't have to know that now you've migrated service B or C over and you're no longer calling the monolith. It can also provide some added benefits. For example, if you wanted to add TLS or SSL, as it's also called, like you wanted to secure the communication, the API gateway can you can add that functionality very easily using the API gateway. API gateways support, providing TLS. It can also provide rate limiting, or it can have other features like if it detects, some failures and stuff, it can provide sort of, circuit breaking and other things. So depending on the API gateway of your choice, it can add a lot of features to all your services with very little cost. All of these features are built into the API gateway that you might have. So you get all those benefits with that.
So then finally, there is the true microservices, the end goal that we've been shooting for all along. You'll see that the API gateway is still a key component. Eventually, we could get to a place where we don't need that. We can have something like a service mesh with Istio or something like that to control all the communications. But we still consider it a true microservices place, even though we have the API gateway involved. And at this point, we've basically taken the previous one and started spinning up these extra services, right? Service B, service B through service N. And now we've got all that good stuff. Everything we talked about in why microservices and containerization and cloud native design gets our business. We can scale every service individually. Each one has its own life cycle. So we've seen customers who've gone from releasing once a quarter to releasing 60 or 100 times a day, because now they can release small things very, 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 very quickly. And that pace of innovation can improve so much just by moving to this type of model. The downside, of course, it's harder to manage.
Yes.
Right? Or different to manage. Because if you're a company that's used to dealing with a monolith, it requires a change of thinking, because now I've got multiple services with multiple teams are responsible for maintaining those services. I probably need to create some kind of centralized CI/CD system, some kind of configuration management platform, all these kind of overheads which go into orchestrating all of these microservices. But when this happens, when you get to this beautiful state, because you have so much agility and ability to innovate in the application development teams, the company or the business is able to spend so much more of its resources on the thing that actually makes money. Because running the perfect Kubernetes cluster doesn't make money. Well, I mean, maybe for Google, but not for most customers. Whereas being able to innovate and being agile and respond to the market, that's where the true business value is, and this is where you get there. Now, does anybody recognize that pattern? Anyone know what it's called? I wish I'd made this up, but I didn't. This is the Strangler Pattern. So this is an analogy. Yeah, it sounds a bit macabre, doesn't it? It actually comes from a tree analogy. And so the principle goes like this. If you have a big, old, well-established tree, we're in California, so let's call it a redwood. You have a big redwood tree. And then you have, which represents the monolith. And then you have a bunch of vines growing up around that tree. As those vines become more and more mature and stronger and hardier, there comes a point in time at which they are now providing more structural integrity than the tree around which they are growing. If that tree dies and rots away, the structure remains. And that's basically what we're trying to do here. We are trying to build microservices around the monolith such that we've made the monolith obsolete. And we can shut it down and remove it and throw it away and never shed a tear for it ever again. And so that's the basic premise of the Strangler Pattern. And it gives you that flexibility, and it gives you a gradual or partial path forward so you don't have to do everything in one go.
Yeah. And as we mentioned, your organizational processes would need to change as well as you move from one type of architecture to the other. CI/CD is one thing we mentioned. Just increasing developer velocity will have its own challenges. When you have multiple releases going out, imagine doing tens of releases instead of one release a quarter or whatever you're used to. So this allows you to gradually change your posture from a traditional organization to a more agile microservices-based organization as well, with less risk.
All right, finally, profit. At the end of the day, that's what business is all about, right? 3 easy steps: categorize, migrate small parts, build up to the final thing, and profit. All right, so some useful resources. We are very blessed here to have a wonderful set of labs. Please go find the hands-on labs session. You've got all sorts of fancy machinery there to go try out these particular labs. We highly recommend the GKE Best Practices Quick Labs Quest. Shahid and the team put a lot of work into building those out, and they kind of guide you through some of these best practices we've talked about here.
Yeah. And they guide you. There are labs that start from just building your first container and deploying it, to all the way to running, hardening those containers, adding security to your cluster, as well as going all the way to maybe deploying a service mesh and so on and so forth. So you can pick the the expertise level that you have, and you can find a quest or lab related to that expertise level and go from there.
We also have a bunch of open source code samples and templates. The URL is there. Please check them out. We're about nearly 20 repos now, I think.
Yeah.
which show essentially how you would do this in production. And they are templates that you can grab, copy, iterate on, and deploy into your environment to get you started very, very quickly with some of these things.
Yeah. And these are open source. That link will take you to a GitHub, a bunch of GitHub repos that you're free to use. They're under Apache license and open sourced.